I mentioned that this management function that this initiator is doing, you don't want it to be statically assigned to one node because that'll be a huge burden. And besides, this node may suddenly become very active. And if that happens, then you're stymieing the computations that are going to happen here to do this management function. Now, intuitively, if we think about it, if a particular node, let's say node N2, has a weight of 0.8, what does that mean? What that means is that in the upcoming epoch, 80% of the M pages are going to be replaced from this node N2. In other words, N2 is hosting a whole bunch of senior citizens. So it's a node that's not very active, right? If it is an active node, then the replacements candidates are probably not going to come from that guy. And in predicting the future, the initiator is saying that, well, most of the replacements are going to come from here, so its weight is very high. So this information, the weight information for all the nodes, is coming to every one of these guys. So intuitively, if we think about it, the guy that has the highest weight is probably the least active. Why not make him the manager? So the initiator for the next epoch is going to be the node with the maximum weight. Now, how do we determine that? Well, every one of these nodes is receiving not only the min age of the candidate pages that are going to be replaced in the next epoch, but also the weight distribution that says what is the percentage of these replacements that are going to happen in each one of these nodes. So locally, each one of these guys can look at the WI vector that it got back from the initiator and say, I know, given that node N3 has the maximum weight, that's going to be the initiator for the next epoch. So locally, you can make the determination so that for the next epoch, in order to send the age information, you know locally who to send it to. Now let's look at how this minimum age information is going to be used by each node. Remember that min age represents the minimum age of the M oldest pages. The smaller the age, the more recent that page is. And so those are the active pages. So if you look at this as the age distribution of all the pages, then if you draw a line here, then the pages to the left of this line, the minimum age line, are the active pages. And the pages to the right of this, which is the M oldest pages, are the candidate pages that are going to be replaced in the next epoch. This is the information that we're going to use in the way we manage page replacements at every node. So let's see what the action is at a node when there is a page fault. If upon a page fault, I have to evict a page Y, then what I'm going to do is I'm going to look at the age of this page Y. If this age of this page Y is more than the minimum age, then I know it's going to be replaced. Even if I send it to a peer node, it's going to be replaced because that is part of the candidate M pages that are going to be replaced in the upcoming epoch. And therefore, locally, I'll make a decision that page Y has an age older than minimum age, and therefore, I'm going to discard it. Simply discard it. Don't worry about sending it to a peer. Remember that in the description of how page fault is handled, I said that when you have a page fault at a node, I pick one of the replacement candidate and I send it to a peer node to store it in the global cache of the peer node. Well, we don't want to do that if that page is going to be eventually replaced during this upcoming epoch, meaning it has to be thrown out onto the disk. In that case, you might as well discard it right now. So if the age of the page that you're evicting from your node happens to be greater than min age, simply discard it. On the other hand, if the page happens to be less than the min age, then you know that it is part of the active set of pages for the entire cluster. You cannot throw it away. You send it to a peer node Ni. How do you pick Ni? This is where the weight distribution comes in. I know the weight of all the nodes. At the end of this computation, the manager sent me the weight distribution for the upcoming epoch of all the nodes. So I can pick a node to send this page to based on the weight distribution. Of course, I could say, well, send it to the guy that has the highest weight because that's the guy that is likely to replace. But remember that there's only an estimate of what is going to happen in the future. So you don't want to hard code that. Instead, we're going to use some information drawn from these weights, we're going to factor that weight information into making a choice as to which peer we want to send this eviction page to. Chances are that the node that has a higher weight is a likely candidate that I'll pick, but it will not always be the node with the highest weight, because if that decision is made by everybody, then we're going to have a situation where if the prediction was not exactly accurate, we will be making wrong choices. Basically, you can see that this age management, geriatric management, is approximating a global LRU. Not exactly a global LRU, because global LRU, computing that on every page fault is too expensive, so we don't want to do that. Instead, we are doing an approximation to global LRU by computing this information at the beginning of an epoch and using that information locally in order to make decisions. So we think globally in order to get all the age information and compute the minimum age and compute the weight for all the nodes as to how much of the fraction of the replacements are going to come from each one of these nodes. But once that computation has been done, for the duration of the epoch, all the decisions that are taken at a particular node is local decisions in terms of what we want to do with respect to a page that we are choosing as an eviction candidate. Do we discard it or do we store it in a peer global cache? This might sound like a political slogan, but the important thing in any distributed system is, as much as possible, use local information in decision making. So think globally, but act locally. So that's the key, and that's what is ingrained in this description of the algorithm.